determine the convergence or divergence of the following series. So እዚህ ዘጠነኛ ጥያቄ ውስጥ የተለያየ ሲሪስ አለን። So converge ማድረግ አለማድረጋቸውን ቼክ እናደርጋለን። So the A part is the series n plus 2 factorial over n factorial times 10 to the power of n ነው። So ይሄ converge ማድረግ አለማድረጉን ቼክ ለማድረግ ሬሾ ቴስት prefer ይደረጋል። So let an is n plus 2 factorial over n factorial times 10 to the power of n. If this is the nth term, the n plus 1's term will be n plus 3 factorial over n plus 1 factorial times 10 to the power of n ነው የሚሆነው። So using the ratio test, we evaluate the limit of the n plus 1's term by the n's term as n approaches to infinity. This is the same as the limit of n plus 3 factorial over n plus 1 factorial times 10 to the power of n plus 1. Here there is plus 1. Okay, so this got plus 1 ይኖረናል over n plus 2 factorial by n factorial times 10 to the power of n as n approaches to infinity. So ይሄንን rewrite ስናደርገው ምንድነው የሚሆነው? The limit of n plus 3 factorial over n plus 1 factorial times 10 to the power of n plus 1 times n factorial times 10 to the power of n over n plus 2 factorial ይሆናል። ይሄንን ሲምፕሊፋይ ማድረግ ያስፈልጋል። factorization simplify ማድረግም በጣም important ነው። So when we simplify this, the simplification for this becomes n plus 3 over 10 times n plus 1 ይሆናል። Okay, ይሄንን n plus 3 factorial in terms of n plus 2 factorial መግለጽ ነው። So this becomes 1 over 10. Okay, this is a number less than 1. Okay, here ምን አለን ማለት ነው? The limit of the n plus 1's term by the n's term as n approaches to infinity is a number 1 over 10, which is less than 1. Therefore the series converges. So the series converges. Okay, now in B we have a series n starting from 1 up to infinity minus 1 to the power of n plus 1 times n factorial over 1 times 3 times 5 times and so on up to 2n minus 1. Okay, here now series section. So here we use absolute convergence. So let's take the absolute value of this series. Absolute value ውስጥ እናስገባዋለን። So minus 1 the power of n plus 1 times n factorial over 1 times 3 times 5 times and so on up to 2n minus 1. This is the same as the series n starts from 1 up to infinity n factorial over 1 times 3 times 5 times up to 2n minus 1. Okay, ይሄ ያለን So እዚህ ጋር እንመጣና ratio test apply እናደርጋለን። Let's use ratio test to check if this series is convergent or divergent. So use ratio test. So the limit of an plus 1 by an as n approaches to infinity ማለት ምንድነው የሚሆነው? This is the same as the limit of the n plus 1's term means n plus 1 factorial over 1 times 3 times 5 times and so on up to n plus 1 over the n's term is n factorial over 1 times 3 times 5 up to 2n minus 1. Okay, ይሄንን simplification መስራት በጣም important ነው። So the simplified form of this becomes n plus 1 over n 2n plus 1 ይሆናል ማለት ነው። ይሄንን expression ሲምፕሊፋይ ስናደርገው n plus 1 over 2n plus 1 ነው የሚሆነው። as n approaches to infinity this becomes 1 over 2 which is a number less than 1. Therefore this series converges absolutely. So the series n starting from 1 up to infinity minus 1 the power of n plus 1 times n factorial over 1 times 3 times 5 and so on up to 2n minus 1 converge ያደርጋል ማለት ነው። it converges. Okay, the C part ወደ C ስንመጣ ሬሽዮ ቴስት ነው የምንጠቀመው ይሄንን ኮንቨርጀንስ ቼክ ለማድረግ። so let the nth term is 3 times 5 times 7 and so on up to 2n plus 1 over 2 times 5 times 8 and so on up to 3n minus 1 ይሄ nth terማችን ቢሆን automatically our n plus 1's term becomes 3 times 5 times 7 and so on. The last term becomes 2n plus 3 over 2 times 5 times 8 and so on. The last term will be 3n plus 2. Okay, so let's evaluate the limit of the n plus 1's term by the n's term as n approaches to infinity. So this is the same as the limit of 3 times 5 times 7 as n approaches to infinity. So when we rearrange this and simplify, this becomes you can take the rearrangement and simplify. So the simplified form becomes 2n plus 3 over 3n plus 2. Every other terms will be cancelled out as n approaches to infinity. So this limit becomes 2 over 3, which is less than 1. Okay, here we can see that the limit of the n plus 1's term by the n's term as n approaches to infinity is a number less than 1. So the series converges. Therefore, the given series n starting from 1 up to infinity. Now let's see the D part. The series in D is given. So here, to evaluate the convergence or divergence, we first consider the inner expression. First, consider the case term where is k factorial over k the power of k. እዚህ ውስጥ ያለችውን ፓርት ብቻ እናያለን። Here we will apply the ratio test to see what this terms looks like. So use ratio test to determine how the sequence is behaving. So the limit of the k plus 1's term by the k's term as k approaches to infinity ምንድን ነው የሚሆነው? This becomes k plus 1 factorial over k plus 1 the power of k plus 1 over k factorial over k the power of k ነው የሚሆነው as k approaches to infinity. So rearrange ስናደርገው ይሄ ምንድን ነው የሚሆነው? ይሄን rearrange አድርገን ስንጽፈው የሚሰጠን k over k plus 1 the whole k ነው የሚሆነው as k approaches to infinity. This becomes 1 over e which is a number less than 1. So here terms of sequence converge እያደረገ የሚሄድ ቁጥር ነው ማለት ነው። So ምን እናገኛለን ማለት ነው? From this the limit of the k's term as k approaches to infinity 0 የሆነ ይመጣል ማለት ነው። So አሁን ወደ ዋናው ሲሪስ እንመለስና n's root እንጠቀማለን። So use n's root on the ak part where k factorial over k the power of k the whole k እዚህ ላይ n's root እንጠቀማለን so the limit of the n's roots of n factorial by n to the power of n the whole n as n approaches to infinity ምንድነው የሚሆነው this is the same as the limit of n factorial by n to the power of n as n approaches to infinity okay k ወይንም n interchangeably መጠቀም ትችላላችሁ so this is 0 ብለናል okay this is a number less than 1 therefore the given series n starting from 1 up to infinity or k starting from 1 up to infinity is convergent on in E the series is n starting from 1 up to infinity n the power of t times e is the power of minus n where t is an element of real number እዚህ ጋም ratio test እንጠቀማለን so let the nth term is n the power of t times e is the power of minus n so n plus 1's term becomes n plus 1 the power of t times e the power of minus n plus 1 ይሆናል ማለት ነው so using ratio test we can write the n plus 1's term by the n's term እንዴት ተብሎ ይጻፋል this is the same as the limit of n plus 1 the power of t times e the power of minus n plus 1 over n the power of t times e the power of minus n as n approaches to infinity so ይሄ ምንድነው የሚሆነው this is the same as the limit of n plus 1 over n the whole t times e the power of minus n times e the power of minus 1 over e the power of minus n as n approaches to infinity so ይሄንን simplify ስናደርግ ምን ይኖረናል ማለት ነው 1 over e times the limit of n plus 1 over n the whole t as n approaches to infinity so as n approaches to infinity ይሄ term 1 ነው የሚሆነው 1 times 1 over e is 1 over e which is a number less than 1 therefore the given series የተሰጠን series ምንድነው ማለት ነው convergent ነው ማለት ነው okay f ጋር ስንመጣ ሁለት ሲግማ ኖቴሽኖች አሉ ይሄን በጥንቃቄ ነው የምንሰራው the summation of n starting from 1 up to infinity and another summation here k starting from 1 up to n to the power of minus k ነው የሚሆነው so እዚች ጋር ይሄንን ለብቻ በመጀመሪያ እንሰራለን we have to see what it looks like ምን እንደሚመስል so the summation of the first n terms እንደዚህ በተን አድርገን እንጽፈዋለን the first term is to the power of minus 1 the second term is to the power of minus 2 to the power of minus 3 እያለ ነው የሚቀጥለው plus to the power of minus n ድረስ ማለት ነው ይሄ በሌላ አጻጻፍ 1 over 2 plus 1 over 4 plus 1 over 8 እያለ ይቀጥላል 1 over 2 the power of n this is geometric ይሄ geometric series ነው first term 1 over 2 ነው the common ratio is second term ለfirst term ስናካፍል common ratio እናገኛለን the common ratio is 1 over 2 the first term is also 1 over 2 so the partial sum of this geometric series ምን ይሆናል Sn is equals to g1 times 1 minus r to the power of n over 1 minus r this is the formula for partial sum of a geometric series so g1 አለን r አለን substitute እናደርጋለን 1 over 2 into 1 minus 1 over 2 the power of እዚህ ጋር the power of n አለ over 1 minus 1 over 2 ይሄን simplify ስናደርገው 1 minus 1 over 2 the power of n አለን okay so ይሄ ኖቴሽን ይሄ ሲግማ ሪዛልቱ 1 minus 1 over 2 the power of n ነው ማለት ነው። so this double sigma notation ወደ ምን reduce ይሆናል ማለት ነው? we reduce this into 1 minus 1 over 2 the power of n ይሆናል ማለት ነው። so using the property of summation ይሄ ምን ይሆናል ማለት ነው? ይሄንን እንደዚህ ልንጽፈው እንችላለን። the summation of a constant minus the summation of a certain geometric series 1 over 2 the power of n 1ን infinitely መደመር 1 plus 1 plus 1 up to infinity ምንድነው የሚሆነው? infinite ነው የሚሆነው minus ይሄ ደግሞ infinite geometric series ነው። so this infinite geometric series result ምንድነው? 1 ነው የሚሆነው. infinity minus 1 is this is infinite. Therefore the given series, this series diverges የሚያደርግ series ነው ማለት ነው። show that this limits the limit of this is 0. okay የm part እንጀምር. so the limit of n the power of n times n factorial over 2n factorial as n approaches to infinity 0 መሆኑን ለማሳየት እዚህ ጋር ይሄንን ፋክት ማወቅ ይጠይቃል። 2n factorial ማለት ምን ማለት ነው? 2n times 2n minus 1 times 2n minus 2 by definition of factorial አንዳንድ እየቀነስን ነው የምንሄደው 2n minus n እያለ አሁንም ይቀጥላል። okay then the next term will be n minus 1 እያለ ስለሚቀጥል ፋክቶሪያል ብዬ አቆማለሁ። so ይሄንን ሰብስቲዩት እናደርጋለን። እዚች ጋር ልንገነዘብ የሚገባው ይሄ በራሱ n ማለት ነው። so ይሄንን ምን ብለን ልንጽፍ እንችላለን? 2n times 2n minus 1 times 2n minus 2 times 2n minus 3 and so on. then we can stop at n factorial. so ይሄንን ይዘን እንመጣና እዚህ ሊሚት ውስጥ እናስገባለን። so it becomes the limit of n the power of n times n factorial over 2n times 2n minus 1 times 2n minus 2 times 2n minus 3 and so on. the last term will be ended at n factorial as n approaches to infinity. አሁን ፋክቶሪያል በፋክቶሪያል ይጣፋል። now we compare the highest degree on the numerator and the denominator. so የኑሜሬተሩንና የዲኖሚኔተሩን ዲግሪ ኮምፔር እናደርጋለን። here we have n, here we have more than n. so ምን ይሆናል ማለት ነው? የዚህ ሊሚት obviously 0 ይሆናል ማለት ነው። okay so this is how we show the limit for a part. okay now let's see the b part. አሁንም ወደ b part ስንመጣ the limit of n the power of t times e the power of minus n as n approaches to infinity. ይሄ እንዴት ሊጻፍ ይችላል? we can write this like the limit of n the power of t over e the power of n as n approaches to infinity ብለን መጻፍ እንችላለን። አሁን ዳይሬክትሊ ቢግ ነምበር ሰብስቲዩት ብናደርግ ኢንፋናይት ኦቨር ኢንፋናይት ነው የሚሆነው። so we need ኤልሆፒታል ሩል ተጠቅመን ዴሪቬት እናደርግ። so the limit of n the power of t derivative over e the power of n derivative as n approaches to infinity. so derivative with respect to n ነው የሚሆነው። so ይሄ ምንድነው የሚሆነው ማለት ነው? this is the same as the limit of t times n the power of t minus 1 over e the power of n derivative ራሱ e the power of n ነው የሚሆነው። አሁንም nን ብናስገባ infinite over infinite ነው የሚሆነው። so we keep doing this L'Hopital rule. አሁንም L'Hopital rule ስንጠቀም we take the derivative of the things here over the things here. ምን ይሆናል ማለት ነው? this becomes t times t minus 1 times t the power of n minus 2 over e the power of n as n approaches to infinity. አሁንም ልናይ የሚገባው still it keeps infinity over infinity. አሁንም infinity over infinity ሆኖ ነው የምናገኘው። so በተከታታይ ኤልሆፒታል ሩል ስንጠቀም እቺ ዲግሪ 0 እስክትሆን ድረስ ኤልሆፒታል ሩል ስንጠቀም እቺን ቲ አርጉልኝ። okay so ምን እናገኛለን? we will get the limit of t times t minus 1 times t minus 2 up to 1, okay, over e the power of n as chigamani inorana t the power of 0 inorana, which is 1. So this becomes the limit of t factorial over e the power of n as n approaches to infinity. So ይሄ ምንድነው የሚሆነው? t factorial times the limit of 1 over e the power of n as n approaches to infinity. Okay, 1 over very big number 0 ነው የሚሆነው. So t factorial times 0 is 0, therefore the limit of n the power of t times e the power of minus n as n approaches to infinity 0 ነው የሚሆነው ማለት ነው። Let an is 5 over n square if n is even, or 2 over n square if n is odd. ይሄ sequence ተሰጥቶናል. So we are asked to show or to verify two things. አንደኛው የተጠየቅነው the limit of the n plus 1's term over the n's term exist እንደማያደርግ ሲሆን ሌላኛው the series converge እንደሚያደርግ አሳዩ ነው የሚለው። So let's see the first part. ሊሚቱን ቼክ እናድርግ. So let's see different cases. The first case can be አንደኛው ኬዝ የምንወስደው ምንድነው የሚሆነው? if n is even n plus 1's term የምንለው ይሄ odd term ነው። n even ከሆነ n plus 1 odd ስለሚሆን n plus 1 ምንድነው የሚሆነው? 2 over n square ነው የምወስደው and n የምለው ደግሞ 5 over n ነው በተሰጠው መሰረት 5 over n square ነው የሚሆነው። So የዚህን ሊሚት ነው ኬዝ 1 ላይ let's see the limit of the n plus 1's term over the n's term as n approaches to infinity ምንድነው የሚሆነው? 2 over n square ለ5 over n square እናካፍላለን። So we evaluate this limit. ይሄን ሊሚት ስንሰራ 2 over 5 ነው የሚሆነው። Okay, so እዚህ ጋር ያዙልኝ the limit of the n plus 1's term over the n's term as n approaches to infinity ምንድነው? 2 over 5 ነው። Let's see the second case. ሁለተኛው ኬዝ if n is odd አሁን ምን ይኖረናል? n plus 1's ተርማችን ምንድነው የሚሆነው? 5 over n square ነው የሚሆነው and the n's term becomes 2 over n square. አሁን ሊሚቱን እንስራ። the limit of n plus 1 over the n's term as n approaches to infinity ምንድነው የሚሆነው? the limit of 5 over n square over 2 over n square as n approaches to infinity. This is 5 over 2. አሁን ሁለቱን ኮምፔር እናደርግ። የመጀመሪያው ኬዝ ላይ ያገኘነው 2 over 5 ሲሆን ሁለተኛው ኬዝ ላይ ያገኘነው 5 over 2 ነው የሚሆነው። So ሊሚቱ ዩኒክ አይደለም ማለት ነው። You see, if you compare these two, the limit are different. Therefore, limit ደግሞ exist ካደረገ ዩኒክ መሆን አለበት። Therefore, the limit of the n plus 1's term over the n's term as n approaches to infinity does not exist እንላለን። ወደ ሁለተኛው እንመጣለን። አሁን ይሄንን ቬሪፋይ አድርገናል። እዚህ ጋር ደግሞ ምን ይለናል ሌላ ጥያቄ the series n starting from 1 up to infinity an converge እንደሚያደርግ እናሳያለን እዚህ ውስጥ የተለያየ ነገር ነው ያለን odd ሲሆንና even ሲሆን የተለያየ terms ነው ያለን for odd 1 up to infinity we use 2 over n square for even we use 5 over n square right so ይሄ እንዴት ሊጻፍ ይችላል this is the same as 2 times the summation n starts from 1 up to infinity 1 over n square plus 5 times the summation n starting from 2 up to infinity 1 over n square so obviously this series is convergent by p series this is also convergent p 2 ስለሆነ by convergent p series converge ያደርጋል ማለት ነው therefore the series an 1 up to infinity converge ያደርጋል ማለት ነው find the values of x each of the following series converge absolutely conditionally or diverge okay x ምን ቢሆን ነው እነዚህ የተሰጡን ሲሪስ ኮንቨርጅ የሚያደርጉት ወይም ዳይቨርጅ የሚያደርጉት የሚል ጥያቄ ነው so the a part we have a series n starting from 1 up to infinity x the power of n over n plus 1 ይሄ ተሰጥቶናል here we use generalized ratio test so generalized ratio test ነው የምንጠቀመው የx ዋጋ determine ለማድረግ so using generalized ratio test let r is the limit of in the absolute value the n plus 1's term over the n's term as n approaches to infinity if this is our r and the n's term is n termation or the n's termation x the power of n over n plus 1 ቢሆን from this we can see that the n plus 1's term ምን ይሆናል x the power of n plus 1 over n plus 1 ላይ አንድ እንደምራለን n plus 2 ይሆናል so ይሄንን ሊሚት ኢቫሉዌት እናደርግ so the limit of this becomes x the power of n plus 1 over n plus 2 over x the power of n by n plus 1 as n approaches to infinity so this can be written as the limit of x the power of n plus 1 by n plus 2 times n plus 1 over x the power of n as n approaches to infinity አሁን ሪአሬንጅ አድርገን ሲምፕሊፋይ ስናደርግ የምናገኘው ምንድነው የሚሆነው this is the same as the limit of the absolute value of x times n plus 1 over n plus 2 ነው የሚሆነው as n approaches to infinity so this is absolute value of x times the limit of n plus 1 over n plus 2 as n approaches to infinity so here limit sannai the limit of this part is 1 times absolute value of x is absolute value of x okay so r ምን ሆነ ማለት ነው r is absolute value of x so generalized convergence test ምንድነው የሚነግረን if r is less than 1 the series converges so r is less than 1 ማለት absolute value of x is less than 1 ማለት ነው which is x is between -1 and 1 therefore the series converges if x is between -1 and 1 ያ ማለት for any other x values diverge ያደርጋል ማለት ነው now let's see the b part እዚህም ጋር ምንድነው የምጠቀመው generalized ratio test ነው የምጠቀመው so our an is let our an is the nth term is n times x the power of n the whole square ይሄ nth terማችን ቢሆን the n plus 1's term ምን ይሆናል ማለት ነው n plus 1 times x the power of n plus 1 the whole square ይሆናል ማለት ነው ኦኬ ይሄንን ሪራይት ብናደርገው የምናገኘው n square times x the power of 2n ሲሆን ይሄኛውን ደግሞ n plus 1 the whole square times x the power of 2n plus 2 ይሆናል this is the n and the n plus 1's term so r is the limit of the n plus 1's term over the n's term ሲሆን this means the limit of we have to put this in the absolute value the limit of the n plus 1's term is n plus 1 the whole square times x the power of 2n plus 2 over the n's term means n square times x the power of 2n as n approaches to infinity so ይሄንን simplify ስናደርግ የምናገኘው this is the same as the limit of in the absolute value x times n plus 1 over n the whole square ነው የሚሆነው this is the same as absolute value of x times the limit of n plus 1 over n the whole square as n approaches to infinity ይህንን ሊሚት ስናየው 1 ነው የሚሆነው 1 times absolute value of x is absolute value of x so this implies our r becomes absolute value of x so by generalized convergence test this r should be less than 1 so that the series converges ይሄ ምን ይሆናል ማለት ነው -1 less than x x less than 1 therefore the given series n starts from 1 up to infinity n times x the power of n the whole square converges if x is between -1 and 1 unfortunately ሁለቱም ተመሳሳይ x value ነው ያላቸው